Okay, so question 1, you have this rotating wheel, and there's essentially a piece of clay or something, a lump of clay, I guess, that is attached to this rotating wheel. So the wheel is rotating about this point, and it's rotating counterclockwise, so it rotates like that, and it's in uniform circular motion. Okay, and there's this piece that flies off, and as it loses contact with this wheel, it of course flies off tangentially to its direction of motion. That's basically Newton's second law, essentially, that once it loses contact with the wheel, the only force acting on it is going to be gravity. The wheel is no longer going to exert a force on it. So basically, according to Newton's second law or first law, it basically continues with the velocity that it was initially moving in. As it was moving in a circle at this instant of time, the direction of the velocity vector was tangential to its direction of motion, which is that. And when it loses contact, it continues to move in this direction, at least initially. Then, of course, the acceleration vector kicks in. The acceleration vector, of course, being pointing downwards. Okay. So first of all, we have to figure out that you are given essentially this height h. आपको ये नहीं, this has lost contact with the rotating wheel. So then once it loses contact, it goes and hits like that. Okay. Wheel भी पीछे रह गया, wheel को कुछ नहीं, wheel इधर ही घूमता रह गया. Okay, that's what is happening. The height h is given from the floor. The radius of this wheel is given, so you know that is capital R. Okay, and what else is given? You know essentially the distance of that this makes with the from the wall, that is given to you. Okay, so the only thing that you then need to figure out is basically that it basically happens to fly off the rim at a 5 o'clock position. What does that mean? This is the 12 o'clock position. This, the vertically below, is 5 o'clock, 6 o'clock position. What's this position? 3 o'clock position. There's a 4 o'clock position, there's a 5 o'clock position. This is 5 o'clock, this is, well, this is supposed to be 5 o'clock, so let me redraw it. बाद में मैंने पढ़ा कि ये 5 o'clock पे जा रहा है, okay? But anyway, okay, so you have this as 5 o'clock, and then you have 4 o'clock, and then this thing goes off as that. Okay, so this is 5 o'clock, this is 4 o'clock. Okay? So I need to essentially figure out first of all the direction of the initial velocity. I start my clock just after this piece of clay loses contact with the wheel, because I'm really interested in what happens to this piece of clay once it loses contact. Okay, does it hit the wall or not? If it hits the wall, where does it hit the wall? Okay, okay. So what do we mean by the initial velocity? We mean, of course, the velocity of this piece of clay at the instant when it lost contact with the wheel. So we need to know the direction in which the rim of the wheel was moving at the 5 o'clock position when it lost contact. Because the initial velocity of this piece of clay will be exactly the same as the velocity of this point on the rim. Okay, just like if you have a thread of string, you tie it to a rock, tie it to rock, and then rotate this in a vertical circle. As this thing is rotating, if I say that you cut the thread when the rock is over here, in which direction does the rock initially move? Moves in that direction, tangential to the circular path. Exactly the same thing over here. The piece of clay loses contact, it initially moves tangentially to the circular path that it was initially moving in. Okay, so we need to know the angle that this initial velocity vector makes with the horizontal. Okay, so इन्होंने thankfully जो है, what has been given to us are these distances with respect to this. So of course I can set up the origin of my coordinate system over here, stationary with respect to the ground. This origin is not moving along with the wheel, so that the initial position vector of my piece of clay is 0. The piece of clay starts moving from the origin of my coordinate system. Okay. The piece of clay, once it loses contact with the wheel, undergoes a constant acceleration of g pointing downwards. Once you have constant acceleration, the first thing that you need to do is to say that, okay, I can find out the position vector straight away. The position vector in such a case will be just be the initial position vector plus the change in the position vector due to the initial velocity, which is u times t, plus the change in the position vector due to the acceleration vector, which is half at square. Okay. So essentially that's what I'm going to do. Once I know the position vector, I know where the piece of clay is at any given time. And then I can deduce that does it hit the wall or not. If it does hit the wall, where does it hit the wall? Okay. Okay. So that's my basic strategy. Well, I mean, set up a roadmap first for yourself. Okay. So first of all, I have to write down over here that I've made this equal to 0 by setting up the coordinate system over here, the origin of my coordinate system over here. These are the x's I use. This is my x unit vector, this is my y unit vector. Okay. Then I just have to write down the initial velocity vector. As in, I need to figure out, for example, this angle, theta. What is this angle? So let's figure it out. Okay. So the zoomed in diagram. Okay. You have here, you have this, and then you have, so basically this angle between 3 o'clock and 6 o'clock, the angle between 3 o'clock and 6 o'clock is 90 degrees, and that is being divided into these 3 equal pieces. There's an arc between 3 and 4 o'clock, then there's an arc between 4 and 5 o'clock, then there's an arc between 5 and 6 o'clock. Okay, and all these arcs are basically the same. Okay, if you take out an arc, they are basically exactly symmetrical to each other. So basically, the total angle is 90 degrees. That is being divided into 3 equal pieces. So each of these angles is 30 degrees. Okay, so basically you have over here that this angle is 30 degrees, and then the velocity vector is like that, is pointing like that, and you are interested really in this angle, theta, right? And this, if you remember from your basic knowledge of circles, the radius is perpendicular to any tangent that you draw to the circle. So this angle is going to give you, this angle over here is going to, is basically, I can draw a horizontal over here. Let me just draw it very clearly. If I draw a horizontal from here to here, then I end up with this right angle triangle. Okay, and if this angle is 90 degrees, if this angle is 30 degrees, this angle is 90 degrees, what's this angle? This is 60 degrees, okay, and this is 90 degrees. And so if this is 90 degrees and this is 60 degrees, what's this angle? 30 degrees, okay. So basically the velocity vector is making an angle of 30 degrees with the horizon. Okay? Okay? इतने शक से क्यों देख रहे हो? All I did was use the fact that the radius is perpendicular to the tangent. हाँ. कहीं और बना दो. That have just changed this thing. Okay, but then you are also, that doesn't change your answers, because that is also going to change the mathematical description of the position of the wall. So that will cancel out when you want to analyze that does the projectile hit the wall, because then you are simultaneously looking at the position vectors of 2 things and comparing them. It's basically like, you know, if x is equal to 2, you add 2 to both sides of the equation, that's still true. So basically by adding some position vector to one position vector equals another position vector, you add the same position vector to both sides, of course that's still true. By changing the origin, that's essentially what you do. Okay? You change the position vector of the wall in exactly the same way that as you change the position vector of the piece of clay. So it doesn't matter where you place the origin. Of course, you would like to that that constant vector to be as simple as possible, just for mathematical simplicity. So you want to set it to 0 whenever possible. Okay. Okay. So you have that u vector. Now let explain. U vector will just be equal to u cos theta ex plus u sin theta ey. Okay. Right. Okay. And then, right, so I have what goes over here. Then I need to write down what goes over here, which is minus g ey. Okay. I don't know one thing over here. Just keep track of which things are those whose numerical value I know and which things are those whose numerical value I don't know. So theta I know now. Theta, you can just even write in brackets, theta equals to 30 degrees. So I know theta. I don't know u, right? But can I figure out u? Because you know how the wheel is rotating. The speed with which this piece of clay went off equals the speed of a point on the rim. Because initially this piece of clay was moving at the same speed as a point on the rim. Otherwise this piece of clay would be sliding on the rim if it didn't have the same speed. But it's not sliding on the rim initially. Once it gets loose, it keeps on moving with the same initial velocity that it had, just like the situation where you cut the string. Okay. So we can figure out the initial speed of this piece of clay by looking at the speed of a point on the rim of this wheel. And how do we do that? Well, you have the radius of this wheel, 20 centimeters. You know the angular velocity of the wheel. That's one way to do it. You know the time period. Right? So you know essentially the angular velocity of the wheel. Right? The angular velocity would be that the wheel covers an angle of 2 pi, sweeps out an angle of 2 pi. Because it's uniform, you don't need to worry about changing angular velocity. It sweeps out an angle of 2 pi in time 5 milliseconds. So the angular velocity is 2 pi divided by capital T being 5 milliseconds. And the linear velocity of a point on the rim would then just be this radius 20 centimeter multiplied by 2 pi divided by capital T. Okay. So you have that u is equal to 2 pi over capital T. I don't like to use r for the radius because the position vector is already using it enough as it is. Safe notation that people usually use is just write b. Okay. B is the radius of whatever thing you are dealing with. Okay. Because b is usually used, is seldom used for anything else. Okay. So b is the radius. So anyway, the point being that since you know capital T, you know the radius of this wheel, it's trivial to calculate the numerical value of u. Okay, so you know this u actually as well. Okay, so you know this u, you know this u, you know theta. Okay, and you know a, of course, and then I can write down the position vector of the piece of clay as a function of time. This will be equal to, this is something that you are sick and tired of seeing by now, u cos theta times t. Maybe I write it like this, plus u sin theta times t minus half gt square times ey. Okay, great. So this tells me that as long as the piece of clay is up in the air, that is a tool that gives me the position of the piece of clay. What good is that for? If I want to find out at what height does the lump hit, how do I find that out?
You can use the horizontal vector.
Exactly. You just find out the time at which the lump is about to hit the wall, just about to hit the wall. At that, instead of time, I don't know the full position vector, but I know that at that instant of time, the horizontal component of that position vector must be equal to d, d, a chota d. Okay, this small d is equal to 2.5, and then I can find out the corresponding value of time, and then once I have that time, I can find out at that instant of time what's the vertical component of this position vector. That vertical component I have to add it to h to find out the height at which it hits the wall, because remember I've set up the origin over here. The height is going to be measured from here. So you add in it, okay? That's it. The rest of it is just game on the calculator. Everything is done, okay? So T is equal to, you find out T is equal to T is equal to 2.5 divided by U cos theta. Theta you know, U you know, okay? And then you plug it into the second one, so you get essentially some number, right? You know U sin theta times T minus half gt square. You know T now, you know theta, you know U, you know G, you get in some number. Whatever number you get, add it to H, that's your answer. Okay? Right. This is a question from a previous exam, and the 5 marks that I forgot to remove. मैं कहा चलो आपको पास पेपर्स की याद आ जाएगी. Okay. अच्छा जी, ठीक है. That's not it, by the way. Yes. Sure. किसके? किस चीज़ की? जो the parabol आपको नजर आ रहा है? किसकी है ये? That's a very good question. ये बता क्या रहा है? वो parabola ही आएगा. अगर आप, but here it contains time. That means that as this is flying off, at any instant of time, this gives me this vector. यानी कि ये vector change होता जा रहा है as the object is moving. That is a mathematical description of these arrows. That generates an arrow that tells me that with respect to this point, what is my arrow that gives me the position of this object at time t. That's a mathematical description of these arrows. इसका जो x component will give you the horizontal distance of that object from this point. The vertical component will give you the vertical distance of that object from this point.
How do we find what point will it correspond? आगे क्या करना है?
तो आप बताओ. देखो कुछ तो आइडिया, देखो आप गलतियों से भी सीखते हो ना. आपका क्या व्हाट्स योर बेस्ट गेस के क्या करना है? अपनी गलतियों से क्यों डरते हो? आई मीन क्विज में या एग्जाम में गलतियों से डरो, बट अदरवाइज बिल्कुल ना डरो, क्योंकि गलतियों को ठीक करके ही आप सीखोगे ना. क्या what do you think? What's your best guess? No guess is stupid enough, okay? Trust me, I've seen it all, okay? Once you see कि derivative में d's cancel हो जाते हैं, you see everything, okay? Your guess cannot be any worse than that, okay? So आपके seniors ने बहुत ही जो है ना, they have set the bar at a very very low level, okay? You cannot plumb those depths, okay? कुछ भी बता दो. So ये you know कि भाई कि you are looking for, essentially you are examining this arrow. कि ये इधर है तो ये arrow क्या है? अब I don't know this arrow because I don't, अगर ये मुझे पता है होता है arrows, because I know the height at which it hits on the wall. But I know कि इस arrow का horizontal क्या है component. This arrow is composed of 2 arrows, one horizontal, one vertical. I know the horizontal arrow that this is composed of because that is simply of length d. So using that, I can figure out कि किस time के बाद ये arrow आपको मिलेगा. So as in u cos theta times t is equal to small d. From that I can figure out the time, and then I can figure out कि भाई इसी arrow का vertical component, what's the vertical component of this arrow? That immediately allows me to figure out the height. Okay, think in terms of these arrows. इतना मुश्किल नहीं है जितना आप लोग बता देते हो क्या. अच्छा जी, okay, there you go. The water in a river. Okay, you are to deliver a package. Allah ही खैर करे. Okay. I think just for confusion, I should remove this directly. You have to deliver a package across the river. Yes.
For the previous question, how do we put our in the wall above the edge?
Oh, you assume that? Yeah. So basically, the mathematics will tell you. जो भी आपका numerical answer आएगा, that will tell you whether, if you're getting a sensible answer, then you know. if you probably get, if your assumption is not true, you immediately in physics get something weird. You'll get a negative number, for example, or you'll get the square root of a negative number. That immediately shows you that essentially this thing cannot happen. Okay. Okay. So let's draw the top view. There's the river, top view. There's some flowing water. So let's say that this is flowing with speed capital V. Doesn't matter. Okay. And you are supposed to deliver, and this distance is d, which is equal to 80 meters. Okay. And capital V, and you are supposed to deliver a package across the river. But poor you can only swim at 1.5 meters per second. Okay. I'm not so sure कि वो Olympic level swimmers के साथ कैसे compare करता है, but I'm pretty sure काफी फुसफुसी है. Okay. But anyway, okay. So you have this. Okay. So if you choose to minimize the time you spend in the water, okay, in what direction should you head? What do you mean? How will you minimize the time spent in water?
45 पे जाएंगे. 45 इस तरफ जाएंगे जैसे जाएंगे.
If you choose to, बताओ.
45 like this.
You just have to go to the other bank.
It depends on
Okay, so think about it physically. In which direction will you swim?
Along the river.
So you have to minimize the time. Really, this displacement is what you are concerned with. You're not really concerned with how much downstream you go, how much upstream you go, never mind that. The time that you take to cover this much displacement depends on which component of the velocity. The component of the velocity in the same direction. If you start swimming in this direction, for example, ये कोई angle बना रहा है, and the size of this arrow has some limit. The size of this arrow cannot be bigger than 1.5 meters per second. What have you done? You have made the component of the velocity, this component of the velocity, smaller than what could have been. If you just bother to just keep on swimming that way, sure, you'll go some distance downstream, but never mind. Your velocity across the river is 1.5 meters per second. So the time taken will just be equal to, believe it or not, 2.5 divided by 1.5. Okay, that is your answer. Okay, that is the time taken. And how far downstream will you be carried? Well, during this time, you multiply that with the speed of the water essentially, because you are going to move along with the water downstream. Okay, that's what you expect. Okay, of course you're not convinced. Let me convince you using vectors. Again, of course, वो आपने और भी ज़्यादा unconvinced हो जाना है. Okay, देख के. Okay, let's quantitatively analyze this situation. कौन से आपका object, the motion of which object are you interested in? You. Okay. Okay, so you are interested in the motion of an object of a person. Okay, so you have a person P. You have some observer in the water, मछली, या mermaid, या swimmer, whatever you like. Okay, ठीक है. And you have another person on the ground. Okay, right? This is the ground observer. Because you are really interested in looking at the motion with respect to the ground. This point on the bank is on the ground. This point on the bank is on the ground. Just like if you have a boat that has to go from this point to this point, and the water is flowing in this direction, do you travel in a shorter time or a longer time compared to when you had still water? Shorter time, of course, because the velocity of the boat gets a boost due to the flowing water. Why did you add, why did you now do, if this distance is d, why did you do d divided by the sum of two velocities? Because the sum of two velocities comes about because You're really concerned that with respect to the ground, what's the velocity? You add the velocity of the boat in still water is the velocity of the boat with respect to the ground, because the water is not moving. The velocity of the water is the velocity of the flowing water with respect to the ground. Because your water is moving and the boat is moving with respect to the water, the velocity of the water with respect to the boat with respect to the ground gets a boost. So I'm doing exactly the same thing over here, except it was a complicated because this is a 2D situation, kind of. You're traveling this way, but you're also being carried downstream. But it's basically the same as this idea, that your velocity of the boat gets a boost in flowing water. The time taken to go from one point to the other point would be smaller simply because of this boost. Okay? So that's why we're interested in finding out the velocity of the boat with respect to the ground. How does that change? Or velocity of the person with respect to the ground, sorry, not boat, okay? Aapko boat pe bitha diya, cheating kara diya, okay? So you have this and then you have this. This is how do you measure these velocities? This is the position vector of the person with respect to the ground. This is the position vector of the water with respect to the ground. Water observer, jiski वही velocity होगी जो water की है. This is the position vector of the person with respect to the water. You have a relationship between them, which is this arrow equals this arrow plus this arrow, aka RPG, position vector of the person with respect to ground is equal to position vector of the water with respect to ground plus position vector of the person with respect to water. You differentiate both sides of this and you have the relationship that you want. Position vector of the person with respect to ground equals the position vector of the person with respect to water. Okay, as in, agar pani nahi flow kar raha hota, this would have been the same as that. As in pani nahi flow kar raha, of course, not that, okay, ye main differentiate kar loon. This is equal to that. If the water is not flowing, this would be 0. So this would be equal to that. If the water is flowing, the velocity of you swimming gets a boost due to the flowing water. It may be a detriment, of course, if you're swimming upstream. Okay? ठीक है? तो देख लेते हैं आप, okay? Let me now convince you of कि भाई हाँ yes आपने क्योंकि अपनी स्पीड की वैल्यू जो अक्रॉस द रिवर है उस पर कॉम्प्रोमाइज नहीं करना. You have to maintain that as 1.5. Of course, the net result would be that your velocity with respect to ground won't just be vertical. It would also have horizontal component. That's why you would go downstream as well. But never mind. Okay? So, just look at this. VWG क्या होगा? This is basically the speed of the water with respect to the ground. If I set up my axis like this, ये x है, ये y है. This would just be 2.5 EX. Okay, so let me just write it as VWG EX. This number is equal to 2.5 meters per second. Okay, fine. What is the velocity of the person with respect to the water? ओके आप कहते हो कि शायद यार किसी एंगल पे मैं करूँ. ऑफ कोर्स इस केस में तो ऑब्वियस है कि आपने सीधा ही स्विम करोगे. आप कहते हो नहीं भाई मैं किसी एंगल पे स्विम करना है, जो मर्जी हो जाए. चलो ठीक है, उस एंगल को बना देते हैं, थीटा कोई एंगल. एंड दिस इज द एंगल इन विच यू आर ट्राइंग टू स्विम विद रिस्पेक्ट टू द वाटर. दिस इज द एंगल एट विच जिसमें आप हाथ पाँव मार रहे हो विद रिस्पेक्ट टू द वाटर. ऑफ कोर्स विद रिस्पेक्ट टू सम ऑब्जर्वर ऑन द ग्राउंड दिस इज नॉट द डायरेक्शन इन विच यू आर मूविंग, because the direction in which you are moving is also determined by the flow of the water. ये तो जा रहा है देखो. ये sorry. ये okay, so you have this thing is then VPW. ये चलो उस डायरेक्शन में बना लूँ, मुझे नेगेटिव साइन के साथ नहीं डील करना पड़ेगा. Okay, VPW sin theta EX plus VPW cos theta EY. That's my velocity vector for with respect to the water. This is the velocity vector with respect to the ground. So what's the velocity vector of you swimming with respect to the ground? वो कैसे निकालेंगे आप? ये ऐड कर दो ना. So इतने हैरान हो के क्या देख रहे हो मुझे? Just add the two, okay? You add the two and what do you get? If you add the two, you get VWGEX plus VPW sin theta EX plus VPW cos theta EY. और अगर आपने अक्रॉस जाना है, राइट, दिस इज द वेलोसिटी, ओके, अगर आपने अक्रॉस जाना है, राइट, दिस मल्टीप्लाई बाय टाइम, ये कांस्टेंट है. दिस इज अ कांस्टेंट वेलोसिटी बिकॉज यू आर ऑलवेज स्विमिंग विद रिस्पेक्ट टू द वाटर एट द सेम वेलोसिटी. हाँ, क्योंकि यू आर ड्राइविंग फ्रॉम वन पॉइंट ऑन द ग्राउंड टू अनदर पॉइंट ऑन द ग्राउंड. वो मैंने बोट की भी एग्जांपल दी है दैट एक अगर आप एक स्टिल वाटर में बोट चलाओ, you travel a distance d, that is the velocity of the boat with respect to the water, which is also the velocity of the boat with respect to the ground in this case, because the water is stationary. The time taken to go from here to here would be d divided by v, जो भी वो velocity है. If the water is flowing, the velocity of the boat with respect to the water would be different or be the same as before? नहीं, with respect to the water तो उतनी की उतनी होगी. वो तो इंजन पे डिपेंड करती है. इंजन तो विद रिस्पेक्ट टू वाटर तो उसी तरह मूव करवाएगा. विद रिस्पेक्ट टू ग्राउंड उसकी स्पीड चेंज होगी बिकॉज द वाटर इज ऑल्सो फ्लोइंग. ओके, इट्स द सेम थिंग. अगर आप गाड़ी पे मूव जा रहे हो, आपकी बाजू जो है, ये एक सिंपल सी चीजें मुझे बतानी पड़ती हैं. एक सोचा थी ना ए लेवल्स में, आपकी बाजू इतनी स्ट्रॉन्ग है दैट यू कैन थ्रो ए बॉल विद स्पीड 10 मीटर्स पर सेकेंड. ठीक है, अब मैं कहता हूं आप गाड़ी में बैठ जाओ. ठीक है, दिस इज अ मूविंग कार and then you throw the ball. What's the speed of the ball that you have thrown with respect to the ground? Of course, this is an ambiguous question. This depends on the velocity of the car. अगर कार के डायरेक्शन के आपने मोशन के डायरेक्शन के पैरेलल आपने फेंका है, फिर तो आपकी स्पीड जिस बॉल की आपने फेंकी है अकॉर्डिंग टू द ग्राउंड वो तो कहीं ज्यादा होगी 5 मीटर्स पर सेकेंड से, बिकॉज द स्पीड ऑफ द कार विल गिव दैट एन एडिशनल बूस्ट. अगर आपने ऑपोजिट में फेंका है फिर उसकी स्पीड काफी कम होगी. The speed of the with which you throw the ball with respect to the car will still be 5 meters per second. क्योंकि आपके मुताबिक जिस आप जब थ्रो करोगे आपको तो मैं तो आराम से बैठा हूं, ये बैठी हुई हूं. It's the same thing over here. इसलिए मैं ग्राउंड वाले का कर रहा हूं so that I can take into account the boost that the way that the velocity of the flowing water changes the velocity of the moving object with respect to the ground. Okay. तो ये अब आपका एक कांस्टेंट वेक्टर है. सो दैट मींस दैट एट टाइम t मेरा वर्टिकल डिस्प्लेसमेंट वेक्टर किसके बराबर होगा? वर्टिकल डिस्प्लेसमेंट वेक्टर, इसका वर्टिकल कंपोनेंट मल्टीप्लाई बाय टाइम t. वेलोसिटी कांस्टेंट है, डिस्प्लेसमेंट वेक्टर कैसे आएगा? इसको t से मल्टीप्लाई करो, क्या हो गया है? जुम्मे के आखिर वक्त तक बिल्कुल ही जो निकली पड़ी होती है, ओके, VPW cos थीटा मल्टीप्लाई बाय t is equal to the distance across, जिसको distance across d है. So therefore t किसके बराबर है? t equals d over v, जो था क्या कहते हैं VPW, जो कि 1.5 है आई थिंक, क्या था, हाँ 1.5 cos थीटा. तो अब बताओ कौन सी थीटा की वैल्यू मैं चूज करूं सच के ये सबसे छोटी वैल्यू आएगी t? 0. That's exactly what I said in the beginning. Don't care about the flowing water. You just flow, you just swim like that. That is just mathematics to prove that theta is equal to 0 leads to the smallest value of time. देखा, मैंने कहा था ना, आपने देख के कब कन्विंस होना है, आपने और अनकन्विंस्ड हो जाना है. ओके ओके, बट ट्रस्ट मी, दिस इज वेरी वेरी सिंपल. इधर कोई इंटीग्रेशन नहीं, कोई डिफरेंशिएशन. लेट मी जस्ट स्केच इट आउट अगेन. You are interested in the velocity of the person who is swimming with respect to the ground. Okay, you know the velocity of the person with respect to the water. उसका मैग्नीट्यूड आपको पता है, आपको उसका डायरेक्शन नहीं पता. यू आर ट्राइंग आउट द डायरेक्शन इन विच दैट पर्सन शुड स्विम विद रिस्पेक्ट टू द वाटर सच दैट द टाइम इज मिनिमाइज्ड. तो आप उसके डायरेक्शन को अननोन छोड़ दो, उसको थीटा मैंने बना दी. ओके, then you find out, then you say that the river is flowing, you set up a coordinate axis, the river is only flowing in the x direction. ठीक है, तो रिवर की वेलोसिटी आ गई आपकी, the velocity of water with respect to ground only has x component, जो कि ये है, this is the vector. Okay. The velocity of the person, swimmer with respect to the ground is relates to these two the other velocities in this way. Yet if I know these two velocities, I immediately know the velocity of the person with respect to the ground. This is the same thing as if the car is traveling forward at a speed of 10 meters per second, I throw a ball with respect to the car at a speed of 5 meters per second. What's the speed of the ball with respect to the ground? 10 plus 5 equals to 15 meters per second. This is exactly the same thing, except of course I could be throwing the ball straight up. I could be throwing the ball opposite direction to the motion of the car. This takes into account all those possibilities because I'm adding vectors. ये वही है कि गाड़ी से मैं बॉल थ्रो कर रहा हूँ और कुछ भी नहीं है ये. ओके, सो दैट्स दैट यू प्लग इन योर वेक्टर्स इन टर्म्स ऑफ थीटा, जो कि आपको पता है. आपको अब ये जो आपकी डिस्प्लेसमेंट वेक्टर जो है ये वेलोसिटी वेक्टर है. सो इफ द स्विमर स्टार्ट स्विमिंग एट टाइम 0 फ्रॉम दिस पॉइंट एट टाइम t, उसका वेक्टर क्या होगा? पोजीशन वेक्टर. यू जस्ट मल्टीप्लाई द वेलोसिटी वेक्टर बाय टाइम t. देयर इज नो एक्सेलरेशन ओवर हियर. इनिशियल पोजीशन वेक्टर आपके स्विमर का 0 है. दिस मल्टीप्लाई बाय टाइम t गिव्स यू द पोजीशन वेक्टर ऑफ द स्विमर एट टाइम t. अब जो भी पोजीशन वेक्टर बनता है, ये जनाब अली इधर आप पहुंच जाते हैं, और तो मुझे ये तो नहीं पता, बट आई नो कि ये क्या है कंपोनेंट इस वेक्टर का. दिस कंपोनेंट ऑफ द वेक्टर इक्वल्स द width of the river, which is 2.5. And in terms of this vector that we written down, that just means कि इसका vertical component multiplied by time t equals the width of the river. अब आपने इस एक्सप्रेशन को देखना है, ऑफकोर्स उल्लुओं की तरह इसको डिफरेंशिएशन ना करने बैठ जाना कि हाउ डू आई मिनिमाइज टी विद रिस्पेक्ट टू थीटा. इट्स ऑब्वियस फ्रॉम हियर कि विच वैल्यू ऑफ थीटा लीड्स टू द स्मॉलेस्ट वैल्यू ऑफ टी. यू हैव टू चूज द मैक्सिमम वैल्यू ऑफ कोसाइन थीटा. डिनोमिनेटर को जितना बड़ा करोगे उतना छोटा टी आएगा. कौन सी वैल्यू ऑफ थीटा चूज करूं तो कॉस थीटा सबसे बड़ा होता है 0. सो यू जस्ट स्विम स्ट्रेट अक्रॉस. ओके, विद रिस्पेक्ट टू द वाटर, with respect to the ground, you will be carried downstream. How much will you be carried downstream? Calculate the time taken for you to swim across. That immediately plug that time over here. Theta 0 है तो ये वैसे ही उड़ जाता है. You just get VWG multiplied by time t. That's the distance that you go downstream. That's it. Okay. ये समझ लो, सिंपल सा एडिशन सब्ट्रैक्शन है, मल्टीप्लिकेशन है, और तो कुछ भी नहीं था. इतना क्यों जो है वो, अगर ये अगर मैं क्विज में देता था आप सबने दूर जाना था. ओके, अच्छा, द फन पार्ट इज पार्ट बी, बिलीव इट और नॉट. ओके, ये तो दिस वाज द प्रोलॉग. ओके, इफ यू मिनिमाइज द डिस्टेंस डाउनस्ट्रीम दैट द वाटर कैरीज यू, इन व्हाट डायरेक्शन शुड यू हेड? हाउ डू यू डू दिस? You basically want to, अब देखो एक तो अगर आप स्ट्रॉन्ग इनफ स्विमर होते, तगड़े होते, जिम ज्यादा जाया करते, मे बी यू वुड एंड अप एट अ पॉइंट डायरेक्टली अक्रॉस. व्हाट डज दैट मीन? व्हेन वुड यू एंड अप एट अ पॉइंट डायरेक्टली अक्रॉस in terms of these velocities? What should be the velocity vector for you, the person P, with respect to the ground? What's so special about the velocity vector in this case that you end up directly across? उसका horizontal component 0. Then you end up directly across. As in पानी तो उस डायरेक्शन में फ्लो कर रहा है, so you probably have to swim in that way such कि ये जो आपका ये horizontal component है, that balances out the flowing water. लेकिन वो आप कर नहीं सकते क्योंकि आप बहुत ज्यादा कमजोर हो. 1.5 times sin theta will always give you a number less than 1.5. That can never balance out 2.5. तो आपने जाना ही जाना है डाउनस्ट्रीम. लेकिन जिस हद तक कम कर सकते हो डाउनस्ट्रीम वो करो. वो कैसे करोगे? आपने वो तो you just भाई आपने जो है you have to go across and you have to minimize the time that you go that you have to minimize the distance that you travel downstream. Okay. So ये आपका थीटा है. अब देखो वो पार्ट ए को इस तरह करने का फायदा हो गया ना. You can immediately generalize it to other situations, okay, whatever framework you set up. Okay. So you have that this is velocity of the person with respect to water. This is the magnitude of that vector, of course. And basically आपने थीटा इस तरह चूज करना है such that this horizontal speed becomes as small as possible. Okay, right? तो वो किस एंगल पे करूंगा तो सबसे छोटी आएगी. आपने ये वाली स्पीड, टोटल स्पीड आपने ये वाली सबसे छोटी करनी है. किस डायरेक्शन स्विम करोगे? पानी के अगेंस्ट स्विम करोगे तो सबसे छोटी आएगी. लेकिन मसला सिर्फ ये है कि जब पानी के प्योरली अगेंस्ट स्विम करोगे क्रॉस कैसे जाओगे? ओके, क्या चीज? हाँ वो क्रॉस किया. लेकिन अगर देखो you want to minimize the time, minimize the velocity in this direction. So your first inclination was कि मैं इस तरफ मैं swim करना शुरू कर देता. ठीक है, मसला ये फिर आप क्रॉस ही नहीं जाओगे. That means that the time taken for you to cross this river will be infinity in this case. कभी भी नहीं आपने पूछना. Okay, so but you आपने पूछना भी है. Okay, of course इस केस में the distance that you travel downstream will also end up to be infinity. क्योंकि अभी भी आप उसी डायरेक्शन में मूव कर रहे हो overall. Because the speed of the water in this direction is bigger than what you have over here. The water is flowing at 2.5. You are swimming at 1.5. You are still traveling at 1 meter per second that way. So आपने वो भी ख्याल रखना कि टाइम जो आपको लगे क्रॉस करने में वो भी बहुत ज्यादा ना हो, लेकिन वरना आप बिल्कुल ही डाउनस्ट्रीम. तो ठीक है, ओके से कि भाई ओके मैं किसी एंगल पे जाता हूँ. थीटा, दिस इज VPW. What's the time taken to cross it? The time taken to cross it, the time taken to cross it will be d, जो कि आपका 80 meters है, d divided by d divided by VPW cos theta. Yeah, the numbers नहीं डालेंगे. Yeah. So this is the time, the distance across divided by the speed across. ये VP, हाँ ठीक है. Okay, because the flowing water only has a horizontal component. Okay, the distance downstream उसको S कह दो. The distance downstream equals क्या? 2.5 देखो शुक्र है एक जो है जाग गया है फाइनली. ओके थैंक यू, वरना मैं समझ रहा था कि बिल्कुल ही गिर है. कोई हाल नहीं. ओके ओके माय फेथ इन ह्यूमैनिटी हैज बीन रिस्टोर्ड. ओके सो एनीवे, सो यू हैव that this thing will be equal to distance downstream will be equal to 2.5. उसको कर देते हैं VWG. VWG minus VPW sin theta multiplied by time. Thank you. ठीक है, and time equals to that. So this is equal to D over VPW cos theta. तो अब थीटा अब ऐसे चूज करना है सच के ये एस की स्मॉलेस्ट पॉसिबल वैल्यू आए. देखो एक दरिया और एक स्विमर के साथ मैं कैसे कैसे प्रॉब्लम निकाल लेता हूँ. क्या सिर्फ एक नहर है और एक बंदा है, दैट्स इट. तो आप क्या करोगे? हाउ डू यू मिनिमाइज दिस? अब करो ना जरा. वो जो कह रहे थे सर पार्ट ए में आप क्या कर रहे हैं, आप वो तो प्रोलॉग था. क्या हाउ डू यू फाइंड आउट द वैल्यू ऑफ थीटा दैट मिनिमाइजेस एस? डेरिवेटिव ले लो यार, इतने क्यों कंफ्यूज हो? यू जस्ट डिफरेंशिएट एस विद रिस्पेक्ट टू थीटा. यू नो दिस नंबर, ये नंबर किसके बराबर है? दिस इज 2.5, दिस इज 1.5, दिस इज 1.5. Just differentiate with respect to theta, set the derivative equal to 0, solve for the value of theta. That's it. बाकी काम तो आप A लेवल में एक्सपर्ट हो. Okay. आप कहोगे नाउ माई टाइम हैज़ कम टू शाइन। मसला ये है व्हेन द टाइम फॉर यू टू कम्स टू शाइन, जब क्विज में आता है या एग्जाम में आता है वहां तक आप पहुंच तो नहीं, तो आप शाइन ही नहीं कर सकते। वो तो पहले पहुंचो तो सही हो क्या। ओके, इट्स लिटरली वेरी वेरी स्ट्रेट फॉरवर्ड। आपने एक एंगल पे जानना है, देयर इज अ कंपटीशन बिटवीन टू थिंग्स। व्हेनेवर यू हैव मैक्सिमम पॉइंट और मिनिमम पॉइंट, देयर इज ऑलवेज अ कंपटीशन। इधर कंपटीशन ये है कि अगर थीटा अगर 90 डिग्री सेट करो जिस तरह मैंने प्लॉट किया है, योर वेलोसिटी डाउनस्ट्रीम बिकम्स एज स्मॉल एज पॉसिबल, बट देन द टाइम टेकन टू गो अक्रॉस becomes very very large. The distance that you go downstream depends on your velocity downstream multiplied by time taken to go across. आपका ये सबसे छोटा तब होगा जब ये दोनों एक दूसरे को बैलेंस आउट करेंगे फैक्टर्स। अगर आपने एक फैक्टर को बहुत बड़ा कर लिया, of course you'll get a huge distance downstream. एक केस में आपने अगर आप सिर्फ यूं सीधा जा रहे हो फिर भी आप काफी डाउनस्ट्रीम चले जाओगे, because you're not you're not doing anything to counteract the flow of the water. If you go at an angle, you are also countering the flow of the water, but you're also trying to go across as well. That's all it is. और कुछ भी नहीं है इधर, लिटरली कोई एक्सलेरेशन नहीं है, कोई कुछ नहीं है। इट्स लिटरली स्पीड इज डिस्टेंस इक्वल टू स्पीड मल्टीप्लाइड बाय टाइम। ओके, सारों को इतनी नीचे कौन सा क्विज हुआ है भाई, ये मेरे क्विज के मार्क्स पता चल गए हैं। सो अच्छा जी, क्वेश्चन 3 इज एसेंशियली ऑन द सेम थीम। आपका एक पायलट है, ओके, अ पायलट अटेन्स एन एयर स्पीड ऑफ 480 किलोमीटर पर आवर। व्हेन यू डिजाइन एन एयरप्लेन, बिलीव इट और नॉट, यू आर इंटरेस्टेड इन द एयर स्पीड के विद रिस्पेक्ट टू द एयर, विद रिस्पेक्ट टू स्टेशनरी एयर, मेरी एयरप्लेन की क्या स्पीड होगी। Because the speed of the airplane with respect to the ground depends on the speed of the flowing air. Hello. अच्छा, देखो कितनी वाइब्रेंट क्लास है। बिल्ली आ गई पढ़ने के लिए, क्या ये कौन डर रहा है बिल्ली से? हेलो, वो दूसरा बिल्ला सही बदमाश है जो लेटा होता है वो सुपर स्टोर के सामने होता है, वो तो बदमाशुद्दीन बदमाश है लिटरली। वो कह मैंने नहीं हिलना, जो मर्जी हो जाए। ओके, एनीवे, सो बिल्ली को देखना बंद करो, मैं भी अगली दफा बिल्ली ले आता हूँ कोई यार के इसको अच्छा ओके, सो हाउ डू यू डू क्वेश्चन 3? अगेन यू नो इट्स वेरी सिमिलर टू द प्रीवियस क्वेश्चन। उसमें सिर्फ पानी था, इसमें हवा है। ओके, so there you had basically the swimmer, had the velocity of the swimmer with respect to the flowing water, and then you had the flowing water with respect to ground. So what you were really interested in was the velocity of the swimmer with respect to the ground. Here you are interested in the velocity of the airplane with respect to the ground. That depends on the velocity of the airplane with respect to the air plus the velocity of the air with respect to the ground. एक विद रिस्पेक्ट टू द एयरप्लेन कैसे मूव कर रहे हैं, और फिर उसमें एक एडिशनल बूस्ट मिलेगी क्योंकि हवा भी मूव कर रही होगी। इफ यू हैव गॉन बाय एयर समवेयर, किसी जगह और फिर वापस आए हो, कई दफा वो टाइम में इसलिए भी फर्क होता है। अच्छा, एनीवे, सो ट्राई क्वेश्चन 3 एंड क्वेश्चन 4 योरसेल्फ। ओके, बेसिकली दे आर द सेम एज क्वेश्चन 2। ओके।